Welcome back. In the last videos, we have discussed availability, reliability, and the trade-offs between them. Today, we are tackling an essential topic for both fault tolerance. Fault tolerance systems are designed to continue operating even when parts of the system fail. In this video, we will explore what it means to build fault tolerant systems, why they matter, and the strategies you can use to achieve them. Let's get started. First, what is exactly fault tolerance? Fault tolerance is the ability of a system to continue functioning when even when one or more of its components fail. This is critical in systems that need to maintain high availability and reliability. For example, think about an airline booking system. Even if one server goes down or a database connection fails, the system needs to remain operational so users can still book flights or check their reservations. Let's talk about key concepts in fault tolerance. The foundation of fault tolerance is redundancy. By having duplicate components like servers, databases, or even network connections, you ensure that if one fails, another is ready to take over. For example, cloud services like AWS or Google Cloud allow you to set up redundant servers across different regions. If one region experiences an outage, traffic can automatically be routed to another region without any disruption. Another key concept is failover. Failover is process of automatically switching to a backup system when the primary system fails. It's used in both hardware and software to ensure that failures are handled seamlessly. For instance, in a database setup, if the primary database fails, a replica or backup database can take over the workload automatically, ensuring that the application continues to function without downtime. Graceful degradation allows your system to continue operating at reduced capacity when a failure occurs. Instead of complete outage, non-essential features may be disabled while the core functionality remains operational. For example, if an online store experiences a backend service failure, it might disable product recommendations or advanced search features but still allow users to browse and complete purchase. So, we need to talk about techniques for building fault-tolerant system. And the first technique for achieving fault tolerance is replication. By replicating data across multiple servers or data centers, you ensure that even if one copy of the data is lost or becomes unavailable, the system can continue to operate using another copy. For example, many databases support master-slave replication, where data is copied from a master database to another or more replicas. If the master database fails, a replica can take over without data loss. Load balancing plays a crucial role in fault tolerance by distributing traffic across multiple servers. If one server goes down, the load balancer can route traffic to other servers to ensure the system stays online. For example, in a web application, a load balancer can detect when a server fails and reroute user requests to another server, maintaining availability even in the event of failure. Another important technique for fault tolerance is using circuit breakers. A circuit breaker monitors interactions between services, and when a service is failing or overloaded, it stops sending requests to that service. This prevents a cascading failure from affecting other parts of the system. For instance, in a microservice architecture, if one service starts to fail, the circuit breaker can isolate it and prevent it from affecting the performance of other services, allowing the system to remain functional. Fault-tolerant systems often include self-healing mechanisms. These mechanisms detect failures and automatically attempt to fix them without human intervention. For example, a server might automatically restart or scale up resources if it detects a problem. In cloud platforms, auto-scaling is common self-healing mechanism. When a server becomes overloaded, the platform can automatically spin up new instances to handle the increased load, maintaining system performance and availability. Okay, let's look at a real-world example of fault tolerance in cloud services. Cloud providers like AWS and Google Cloud offer built-in redundancy, replication, and failover across multiple regions. This ensures This ensures that if a data center or entire region goes down, the system continues to operate seamlessly from other regions. So, while fault tolerance is critical, it's important to understand the trade-offs involving first, cost. Achieving a high fault tolerance often requires additional infrastructures like redundant servers and data replication, which can increase operational costs. Second, complexity. Managing a fault tolerant system is more complex, requiring additional monitoring, failover mechanisms, and testing to ensure everything works smoothly. Third, performance. Fault tolerant systems sometimes involve replication or failover that can introduce slight delays or performance overhead. When designing fault tolerant systems, there are some best practices to keep in mind. First, plan for failure. Assume that failures will happen and design your system to handle them gracefully. Use redundancy and failover. Ensure that critical components have backups and implement automatic failover mechanisms to minimize downtime. Third, monitor and test. Constantly monitor your system or failures and regularly test your failover processes to ensure they work as expected. So, to sum up, to sum up, designing a fault-tolerant system involves a combination of redundancy, failover, circuit breakers, and self-healing mechanisms. While it requires careful planning and management, fault tolerance is essential for ensuring that your system remains available and reliable, even when things go wrong. In next video, we will dive into service level agreement and how they define availability and reliability metrics. If you found this video helpful, be sure to give it a thumbs up and subscribe to the channel and hit the notification bell to stay updated. See you next videos.